Good day, everyone, and welcome to Amplifying Searches with Azure Cosmos DB for MongoDB and Natural Language Processing. My name is Cornell Emil. I'm the founder and Information Solutions Architect at App Data Solutions, LLC. During this presentation, we'll be discussing the following items. What are some of the key business needs that this solution addresses? What is natural language processing? Well, I'll show you a quick example of the solution, and then we'll do a deep dive into the solution, covering all of the architectural components and even going into some of the code samples. And lastly, we'll wrap up with next steps. So, what are the business needs that this solution fills? Well, in particular, it identifies suitable candidates to fill job openings. So about 3 years ago, we were presented with an opportunity to solve a major problem for one of our customers. They needed to be able to quickly and accurately identify suitable candidates for the various job openings that they wanted to fill. So in order to develop the solution for them, we decided to leverage Azure Cosmos DB for MongoDB, primarily because of its ability to scale easily and also its flexibility in supporting multiple semi-structured schemas. So within the solution, Azure Cosmos for MongoDB stores various basic profiles about potential candidates, their resumes, notes, and other data elements. And then we combine natural language processing with Azure Cosmos DB for MongoDB to enable searches that are performed quickly over several million documents. And so during this presentation, we'll be diving into how this solution was architected and some of the things that we've learned through this journey. Before we do that, let's talk a little bit about natural language processing. So natural language processing uses machine learning to identify the context of words, language translations, context. It's a lot of different parts to natural language processing that allows computer programs, software to actually be able to interpret words and, of course, the meanings associated with words. So in particular, for our solution here, some of the major value propositions we've been able to tokenize the resumes that we have in our solution into string arrays. The natural language processing removes words such as and the and is. These are generally called stop words, and you'll find them throughout various languages, in particular English. And at times, they don't really provide much value. So we've decided to use natural language processing to remove those words. And of course, we've been able to supplement natural language processing with domain-specific dictionaries. So by this, I'm meaning that we've supplemented the data that we're storing within Azure Cosmos DB for MongoDB with dictionaries that are specific for our customer around the areas of technology, engineering. And by doing this, we're providing an enhanced search capability that addresses their specific search domain criteria in a way that's simply put, is allowing them to search in a way that they never were able to for candidates that are suitable for the job openings that they're trying to fill. So let's quickly look at the solution. So here's a screenshot of the search page. As you can see along the left, there's various different ways, including name, keywords, job titles, location, the distance from a particular radius, and several other options. I've limited the number of options here, but in the production version of this solution, there's upwards of 50 different options available for the user to identify potential candidates. And across the top here, you'll see some of the BSON filter documents that are generated as part of the search. And in the middle here of the screen, there are the results that have been generated. These candidate names they've been redacted in some way to protect, obviously, the information that we have in the solution. But the solution provides quite an enhanced experience by being able to quickly allow the users of the solution to view the results and, of course, be able to begin to search and view the details of each and every one of these candidates. So how does this solution work? Well, let's dive into the architectural design. So firstly, the user inputs data, for example, let's say it's a resume, into an application that's hosted in Azure's app service. The app service then writes the data over into Azure Cosmos DB for MongoDB. Once the data is saved, the application then asynchronously goes and triggers a backend processing that is being handled by Hangfire. Hangfire then makes an HTTPS call to the Tokenizer service. And then that Tokenizer service takes the data out of Azure Cosmos DB, MongoDB for a specific candidate, takes the resume and tokenizes that data, and then creates a string array that is saved back to the Azure Cosmos DB instance. Later, the user comes back and reads that data as part of the search results that you saw in the previous slide. So this is at a high level, the solution. We'll be walking through each of these components on the next few slides. So let's start off our solution deep dive with looking at what the app service is responsible for and a little bit of the code that is used within the app service. So the user enters the data that is being captured for the candidate or the profile. It can be basic information around the name and address, the resume, some additional notes. And then once that information is entered, the application triggers Hangfire's backend process. So you see here within this Visual Studio snippet, there's a method called update tokens that's accepting arguments for the candidate ID, which in this case would be the ID that's been assigned to the document that was previously saved to the MongoDB instance. And also the user identifier along with the username. So once the data is saved to the Azure Cosmos DB MongoDB instance, the application then has called Hangfire. Hangfire makes an HTTPS call to trigger a Tokenizer service. This Tokenizer service is implemented within a function app, which we'll see some of the code in the next slide. But in particular, and very important here, here is that the Hangfire process passes the object ID of the document ID that was created in the previous step, and also information about the user that inputted the data. So you see here within this screenshot that the Hangfire instance has initiated an execute command and passed in the object ID. This here represents my user ID, and of course, here's my name. So once the Tokenizer service is called, it has several responsibilities that are critical for this solution. It firstly must go through and cleanse the data, removing any stop words, tokenizing the data as needed, saving the string array of tokens that are tokenized. And of course, this can be achieved through a number of different NLP packages, but the one that we leverage within this solution is called Spacey. And it's so far proven to be a very reliable NLP package. So here's a code snippet on the right. Code was written in Python, but it shows clearly that there's the passing of values from an array of text into a method called get tokens for both the resumes, tokens, and also the notes. And once these tokens are created, they are then saved to the Azure Cosmos DB MongoDB instance. So you might wonder, well, how does this all look inside of Azure Cosmos DB for MongoDB? Well, here's a quick overview of what you would find if you want to peel back the layers and take a deep dive into the data that is being generated by the token servers. The tokens are saved to an array called resume tokens. And this is one of many different data points that exist within a document. But the resume tokens array essentially contains a string, array of strings that you can see here on the right. So a resume that might contain 1,000 words, 2,000 words, etc., is essentially distilled down to generally about 40 to 50% of the original text of that resume. So this is a quick sample here of my resume, which is about 6 pages long, unfortunately, but it shows how succinctly the tokenizing of the words can simply take a large resume and make it into a much smaller and much more manageable data set. And of course, the data that is being stored in the array is indexed by Azure Cosmos DB for MongoDB, and the index is used to be able to quickly search the entire collection of documents, which today is approaching about 3.5 million documents. And generally, the response time for the results to be returned is somewhere between 3 to 5 seconds, depending on the type of search that the user performs. So during this presentation, I've provided a quick overview of the solution that we've built to enable very enhanced and amplified searches of a tremendous amount of data that's stored for the purpose of matching candidates with job openings. However, that's not where we stop here. So we're excited to continue with next steps around optimizing the queries within the solution. One of the ways that we've started looking at optimizing the queries is by capturing and analyzing the explain plan that is being generated. That's step one. We've got several steps thereafter around optimizing the queries. Next, we're implementing a method to continuously update the dictionaries that are being used within the natural language processing package that the solution leverages to identify keywords that continuously get added to our customers' resumes and their internal processes. And then lastly, we're extending the solution to add the functionality of auto-matching candidates to those job openings without any type of manual intervention. So these are just some of the next steps that we have. It has been a pleasure sharing this solution with you. I hope you enjoy the remainder of the conference, and I hope you've walked away with this from this solution with ideas of your own on how you can leverage Azure Cosmos DB for MongoDB. Thank you all.